Hey guys, today I'm going to solve a problem from electric fields and matter. On this problem, we have a small metallic sphere with a radius big r that carries a charge of negative q, and it is located at a distance small r from the neutral copper wire of length capital L. As you can see in this diagram, this charged metallic sphere will create an electric field around the wire, which will polarize the wire, and then we have the electric forces that the ball exerts on the wire, and then the electric force that this wire exerts on the metallic ball. So we have that relation, the force by ball is equal to force by wire. So we need to calculate the force that the ball exerts on wire. So the force by the ball is equal to the charge on the ball times the electric field of the wire. So in order to calculate the electric field of the wire, we consider the wire as a dipole with a positive q and negative q at the end, at either ends. You can see the enlarged picture, the positive q charge, negative q charge, and the length of the wire is L. So we have the electric field of the wire, which is of dipole, by this formula 1/4πε0 times 2qL over r cube. R is the distance between the metallic sphere and the copper, q is the charge on the wire, and then the L is the length of the copper wire. So in order to calculate the electric field and hence the force, we need to find what is the charge q on the wire. We don't know that charge, so we need to calculate that first. Now to do that, we use this formula. Electric field is equal net electric field on the wire is equal to electric field by ball plus electric field by the positive side plus electric field by the negative side. And we know that the net electric field inside the metal wire is 0 at the equilibrium, so we use the formula for rest of them. The electric field by ball is 1/4πε0 q over r square. Electric field by positive end is 1/4πε0 q over L over 2 whole squared plus 1/4πε0 q over L over 2 whole squared. Since we are assuming that the point we taking is at the middle point of this wire, we have the electric field by positive end, which the distance between that positive end and the middle point is L over 2. So this distance is the midpoint distance from either of the ends. So now by arranging this equation, we get q is equal to big Q, which is the charge on the ball, over 8 times L, the length of the copper wire, divided by R, the distance between sphere and the wire, whole squared. Now we can plug this value into the electric field. We have the force is equal to q times electric field from this equation right here, and the electric field is 1/4πε0 2q L over r cube. We already found the value of this q, so from here we substitute the value of q, and we get the force is equal to 1/4πε0 q square, which is the charge of the ball, times L cube, the length of the copper wire, divided by 4r to the power 5. The r is the distance between the metal sphere and the copper wire. So the rest is pretty much the plugging in all the value. We need to calculate the q first. We use this formula, q over 8 times L over r whole square. We calculate the charge on the wire, and then we calculate the force by plugging this charge into here, and we get our answer. The force and the force that the ball exerts on the wire is 1.4 times 10 to the power minus 11 Newton. Thank you.